Good morning. Today we will discuss about the radar and Internet of Things. Introduction of radar. Radar is acronym for radio detection and ranging. First successfully demonstrated in 1936. It used electromagnetic waves and it enjoyed wide range of applications. Principal working of the radar. So this is the diagram of the basic radar in which a transmitter receiver in the radar and a antenna. The signal is transmitted by the transmitter to the target. The distance between target and antenna is the range of target, and after the transmitting a signal, and that signal find out the target and return in the form of echo signals. And the range equation for the radar, that is the R max, maximum range equations, that is equal to PTG delta AE upon 4 pi square as minimum whole power of 1 by 4. So G equal to 4 pi AE upon lambda square and AE equal to G lambda square upon 4 pi. So R max will be equal to PT G lambda square delta upon 4 pi square as minimum power of whole this 1 by 4, where PR equal to power received and PT equal to power transmitted. G is the antenna gain and delta is the radar cross section of target, and AE is the effective area. So this is the radar range equations. With the help of this radar range equation, we can find out the range of the target from the radar. Types of radar. So radar are two types. First, primary radar and second, secondary radar. And again, primary radar have two types. One is continuous wave radar and second is pulse radar. And again, continuous wave radar have two types, modulated radar and unmodulated radar. And pulse radar is also two types. First one is MTI radar and second is Doppler radar. So these are the types of radar. First, continuous wave radar or CW radar. So this is the block diagram of the CW radar, in which a target, CW transmitter, detector, mixer, and beat frequency amplifier and a indicator. So there are different networks in this CW radars, which is shown in this diagrams. So advantage of radar: use low transmitting power, low power consumption, simple circuitry, small in size. But CW radar have some disadvantage also. Several targets at a given bearing tend to cause confusion. Range discrimination can be achieved only while introducing very costly complex circuitry. So it is not capable of indicating the range of target and can show only its velocity. Next, gated CW radar. In this radar, it operates on the principle of pulse transmit signal and gated receiver path along with IF section of the receiver. This radar does not pass the entire received pulse of frequency, but only the central components. Gated CW radar have generally been implemented using vector network analyzers, VNA as the IF receiver. So advantage of this radar, high level of performance, less cost, better accuracy, sensitivity, selectivity, good data acquisition speed. And disadvantage of this radar is experience additional losses, term duty cycle losses. So this is the disadvantage of this gated CW radar. Next radar is pulse radar. In pulse radar, transmit high power, high frequency pulses toward the target. Choice of pulse repetition frequency decide the range and resolution of the radar. Two broad categories of pulse radar employing Doppler shift are moving target indicator radar and pulse Doppler radar. Next one is moving target indicator radar or MTI radar. This radar uses Doppler effects. MTI radar distinguishes between moving target and stationary target. The MTI radar use low pulse repetition frequency PRF to avoid range ambiguities. MTI radar can have Doppler ambiguities. So principle of this radar, this is the diagram of the MTI radar in which two mixers and a clustron amplifier and duplexer IF amplifier, phase discriminator and a radar display also. So this is the block diagram of the MTI radar. Application of MTI radar in UAVs. So UAV stand for unmanned aerial vehicles. These aircrafts are without pilot on board. One specific area of interest that has been closely examined by the UAV has been in the area of cross queuing application moving target indicator. JSTARS and TESARS are two types of UAVs used by the US Air Force. Next one is the pulse Doppler radar. So in pulse Doppler radar, use high PRF to avoid Doppler ambiguities, but it can have numerous range ambiguities. In MTI radar, the PRF is chosen so that there are no range ambiguities, but there are usually many Doppler ambiguity or blind speeds. A radar that increases its PRF high enough to avoid the problem of blind speed is called a pulse Doppler radar. Resolving velocity ambiguity. Earlier, multiple ERF was used. Velocity ambiguity can be resolved by transmitting many carrier frequency. So F and D equal to N FR plus F and D, where F and D is Doppler frequency, F and D equal to 2BT Fn per C. So FR equal to 2BN Fn per C. Therefore, Vt equal to NBN plus V and T. There are different comparisons between different radar systems. So parameters, type of signals in pulse radar that is modulated, and continuous wave radar that is modulated and unmodulated. Antenna in pulse radar, duplexer, and continuous wave radar separate antenna. Range in pulse radar indicate range. In CW radar don't indicate range. Transmitting power in pulse radar high, but in CW radar that is low. Circuit of pulse radar is complicated, but CW radar is simple. Stationary target in pulse radar affects what in CW radar doesn't affect. Maximum range in pulse radar high, what in CW radar that is low. Practical application of pulse radar, more applications, and practical application of CW radar is less application. So these are the some comparison between pulse radar and CW radar. So radar is used to find velocity, range, and position of the object. Advantage of radar is that it provides superior penetration capability through any type of weather conditions. LIDAR is advanced type of radar which use visible light from laser. Next is Internet of Things. So what is Internet of Things? History, how Internet of Things IoT works, few application of IoT, current status and future prospect of IoT, technology challenge of IoT, and criticism of IoT. So what is IoT? The Internet of Things is the network of physical objects or things embedded with electronics, software, sensors, and network connectivity, which enables these objects to collect and exchange data. So this is the IoT. Things in the context of the Internet of Things, IoT is an entity or physically object that has a unique identifier and embedded system and the ability to transfer data over network. Heart monitoring, implants, biochip transponders on farm animals, automobiles with built-in sensors, DNA analysis device, and other wearables, etc. So these devices collect useful data with the help of various existing technology and then autonomously flow the data between other devices. So in 1999, the IoT gets a name. Kelvin Ashton coins the term Internet of Things and established MIT Auto ID Center, a global research network of academic laboratories focused on RFID and the IoT. How do IoT works? The Internet of Things, IoT, also sometimes referred to as the Internet of Everything, IoE, consists of all the web-enabled devices that collect, send, and act on data they acquire from their surrounding environments using embedded sensors, processors, and communication hardware. These devices, often called connected or smart device, can sometimes talk to other related devices. A process called machine to machine M2M communication and act on the information they get from one another. Human can interact with the gadgets to set them up, give them instruction or access the data, but the device do not do most of the work on their own without human intervention. Their existence has been made possible by all the tiny mobile components that are available these days, as well as always online nature of four of our home and business networks. So Internet of Things life cycle collect the data and communicate, analyze, and act. So this is the Internet of Things life cycle. So collection, device and sensors are collecting data everywhere at your home, in your car, at the office, in the manufacturing plant. And communication, next communication, sending data and events through network to some destination, a cloud platform, private data center, home network. And next one is analysis, creating information from the data, visualizing the data, building reports, filtering data, and paring it down. Next one, action. So taking action based on the information and data communicate with another machine, M2N, send a notification, SMS, email, text, talk to another system. So this is the action of the IoT. So how IoT works? So there is a RFID, next sensor, smart technology, nanotechnology, and to identify and track the data of things. That is the in RFID, and sensor to collect and process the data to detect the change in physically status of things. And next, smart tech to enhance the power of the network by developing processing capabilities to different part of the network. And nanotechnology to make the smaller and smaller things have the ability to connect and interact. So this is the works of IoT. Next, the structure of IoT. The IoT can be viewed as a gigantic network consisting of network of devices and computers connected through a series of intermediate technology where numerous technology like RF ID wireless connections may act as enablers of this connectivity. So tagging things, in tagging things, real-time item traceability and addressability by RFID. In feeling things, sensor act as a primary device to collect data from the environment. Shrinking things. In shrinking things, miniaturization and nanotechnology has provoked the ability of smaller things to interact and connect within the things or smart device. Next, thinking things. So in this, embedded intelligence in devices through sensors has formed the network connections to the internet. It can make the things liking the intelligent control. So this is the structure of IoT. Application of Internet of Things. So there are few applications of IoT. First, building and home automation, manufacturing, medical and healthcare system, in media, in environmental monitoring, in infrastructure management, energy management, transportation, and better quality of life for elderly. So in the world of IoT, even the cows will be connected and monitored. Sensors are implanted in the ears of cattle. This allows farmers to monitor cows' health and track their movements, ensuring a healthier, more plentiful supply of milk. On average, each cow generates about 200 MB of information per year. Current status and future prospect of IoT. So world population is 3.6 billion. So connected device 500 millions. If world population is 6.8 billions, connected device is 12.5 billion, and 7.2 billions connected device is 25 billions, and world population is 7.6 billion, connected device is 50 billions. So connected device per person in 6.3 billions, 0.08, and for 6.8 billion, that is 1.4884, and for 7.2 billion, that is 3.47, and world population 7.6 billion, the connected device per person 6.58. So this is the current status and future prospect of IoT in year-wise. Next, technological challenges of IoT. At present, IoT is faced with many challenges such as scalability, technological standardization, interoperability, discovery, software complexity, data volume and interpretation, power supply, interaction and short-range communication, wireless communication, fault tolerance. So these are some technological challenges of the Internet of Things. Traditional and controversy of IoT, scholars and social observers and pessimists have doubt about the promise of the ubiquitous computing revolution in the area as privacy, security, autonomy, and control, social control, political manipulation, design, environmental impact, influence human moral decision making. So these are the some controversies of IoT. References. There are some multi-choice questions for this topic. So we will discuss these multi-choice questions one by one. Question first, the radar in which both transmission and reception is done using the same antenna are called option A, monostatic radar, B, bistatic radar, C, monopole radar, D, dipole radar. So here correct answer is monostatic radar, the radar in which both transmission and reception is doing using the same antenna are called monostatic radar, or that antenna is called transceiver antenna. So here correct answer is option A. In next questions, increasing the pulse width in a pulse radar. Option A, increase resolution, B, decrease resolution, C, has no effect on resolution, D, increase the power gain. So correct answer is decrease resolution. That is the answer B, correct for this questions. If we increase the pulse width in a pulse radar, in that case decrease resolution. So this is the correct answers. In next questions, a high noise figure in a receiver means high noise figure in a receiver means a pure minimum detectable signal, B, a good detectable signal, C, receiver bandwidth is reduced, D, high power loss. So correct answer for this option B is correct. A poor minimum detectable signals. So a high noise figure in a receiver means a poor minimum detectable signal. So this is the correct answers. In next questions, the sensitivity of a radar receiver is ultimately set by the sensitivity of a radar receiver is ultimately set by a high signal to noise ratio, a lower limit of signal input, overall noise temperature, and D, a higher figure of merit. So here the correct answer is overall noise temperature. So this is the option C is the correct answer of these questions. And next questions, a radar that is used for measuring the height of an aircraft is known as. Measuring the height of an aircraft is known as radar altimeter, radar elevator, radar speedometer, radar altitude. So in this question, radar use the measuring the height of a aircraft, that is the radar altimeter. So option A is correct answer. In next questions, second time around echoes are caused by option A, second time reflection from target. Option B, echo returning from target beyond the cathode tube range. C, echo that arrived after transmission of next pulse. D, extreme end of bandwidth. So correct answer is echo that arrive after transmission of next pulse. So answer C is correct here for this question. Next question, the resolution of pulse radar can be improved by option A, increase the pulse width, B, decreasing pulse width, C, increasing the pulse amplitude, D, decreasing the pulse repetition frequency. So resolution of a pulse radar can be improved by decreasing pulse width. So option B is correct answer, because by decreasing the pulse width, resolution of pulse of radar can be improved. And next questions, in case the radar diameter in a radar system is increased to 4 times, the maximum range will be increased by 1 by 2 times, 2 times, 4 times, 8 times. So correct answer is 4 times. And next questions, the term radar stand for radio detection and ranging, that is option A. Option B, radio detection and ranging. Option C, radio wave dispatching and receiving. Option D, random detection and re-radiation. So radar stand for radio detection and ranging. So here option V is correct answer, radio detection and ranging. Next questions, a large antenna is used in radar because it, option A, give higher gain, B, give lesser side lobes, C, increase the beam width, D, increase bandwidth. So large antenna is used in radar because it gives higher gain. So for higher gain, we use the large antenna in the radar due for the higher gain. So option A is correct answer. In next questions, a radar cross section is affected by radar cross section. Option A, target size and shape. B, target aspects. C, target material and carrier frequency. D, all of the above. So here the radar cross section is affected by target size and shape. That is the correct. Second, target aspect. This is also correct. And third, target material and carrier frequency. This is also correct. So for radar cross section is affected by all of the above options. So answer D is correct. Option 4, this questions. Radar range equations provides a relationship among radar range equation. Provide a relationship among option A, receiver power, option B, target characteristics, option C, R max of the radar, which is determined, and option D, all of the above. So radar range equation provide a relationship among receiver power. This is correct. Target characteristics. This is also correct. And maximum range R max of the radar, which is determined. This is also correct. So there are all options are correct. For the radar range equation provides a relationship among following options. So all options are correct. A random A, option A, radar house in a dome. B, protective cover for the antenna. C, dish-shaped antenna. D, dome-shaped antenna. So a radome is a, that is the protective cover for the antenna. So here correct answer is option B. Radome is a protective cover of the antenna. In next question, the range of a radar can be increased by option A, increase the P transmitted pulse power. B, increase the diameter of the antenna. C, increase the frequency. Any of the above. So here, any above the above, the range of the radar can be increased by any of the above. So range equation proportional to the peak transmitted power, diameter, and frequency also. So here correct answer is option D. In next question, in order to double the radar range, the peak pulse power should be increased by 2 times, 4 times, 8 times, 6 times, 16 times. So if we double the radar range. The peak pulse power should be increased by 16 times, because the pulse power equal to power of 4 of range. In next questions, if the ratio of the antenna diameter to the wavelength in a radar system is high, this will result in indicate the false statement. Indicate the false statement. Option A, large maximum range. Option B, good target discrimination. Option C, difficult target acquisition. D, increased capture area. So here option D is false statement, that is the increased capture area. In this question, if the ratio of the diameter of antenna to the wavelength is radar system is high, this will result in. So correct, so false statement is option D. In next questions, the radar cross section of a target indicate the false statement. Radar cross section of a target here indicate the false statement in this question. So we indicate the false statement within 4 options. So option A, depend on the frequency used. Option B, may be reduced by a special coating of the target. Option C, depend on the aspect of a target if this known spherical. D is equal to the actual cross-sectional area for small targets. So here correct answer is option D. That is the false statement for the radar cross-section of a target. So option A is correct. Depend on the frequency used. Option B, that is true, may be reduced by special coating of the target. Option C is also true for radar cross-section of a target. Depend on the aspect of a target if this known spherical. So in this question, 3 options are correct or 3 statements are true, but statement 4 is false for this questions. So here false statement is option D. A high PRF means pulse repetitive frequency, will indicate the false statement. Option A, high PRF will indicate false statement. Option A, make the return echo easier to distinguish from noise. B, make target tracking easier with conical scaling. Option C, increase the maximum range. Option D, have no effect on the range resolutions. So here false statement is option C, increase the maximum range. So this is the false statement for the high pulse repetitive frequency PRF. So option A is correct, true, make the return echo easier to distinguish from noise. B, make target tracking easier with conical scanning. C is also true, increase the maximum range. So here false statement is option C. So answer is C. Thank you very much.